Today we will be talking about parallel lines and the angles that go with them. We will talk about how to prove angles are congruent, knowing the lines are parallel, and the converse of this.
So first I'm going to show you how if you know two lines are parallel, such as A and B, and one of those lines is parallel to a third line, you know that all three lines are parallel. You know this because when two lines are parallel, they are the same distance to each other for all of eternity because they never intersect. So A and B are always the same distance from each other. And since B is parallel to line C, line B is always the same distance from line C, just like it is from line A. So line A is the same distance from line B, and line B is the same distance from line C. So you know that line A is always the same distance from line C. And if you know that, if they're always the same distance from each other, they never intersect, and that means line A and line C are parallel.
So in this video, we're going to explain why, if you have two parallel lines, that these angles all correspond to each other, such as 1 and 1 correspond to each other due to the corresponding angles theorem, but 1 and 4 correspond to each other due to the alternate interior angle theorem. Alternate interior angles are angles that are on the inside of two parallel lines and on the opposite side of a transversal, such as angle 1 and angle 2.
So now I'm going to show you why, if you know two lines are parallel, like line A and line B, you also know that the alternate interior angles are parallel, or congruent. So if you took line B and slid it up to line A, because they're parallel, then you'd have a line that looks like this, line AB. And then angle 1 would be right here, opposite angle 2. And since you know vertical angles are congruent, and 1 and 2 are vertical angles, you know that they're congruent. The converse of this theorem is that if you know the two alternate interior angles are congruent, but you don't necessarily know that A and B are parallel, you now know that A and B are parallel if you already know that these are congruent.
So for proving that corresponding angles are congruent if you know the two lines are parallel, we're going to use something similar we did proving that if two lines are parallel, you know that the alternate interior angles are congruent. So if you know that A and B are both parallel to each other, you will now know, after I explain this, that angles 1 and angle 2 are congruent. So if you were to slide line A up to line B, like we did in the previous part, you will now see that angle 1 is now overlapping over angle 2. Therefore, angle 1 is congruent to angle 2. So for corresponding angles to prove that two lines are parallel, we just use the converse of the parallel lines proving that the corresponding angles are congruent. So if we know that angles 1 and angle 2 are both congruent, we now know that this line and this line are now parallel, because before we knew that if this line and this line were parallel, these two angles would be congruent.
Now I'm going to show you why same-side interior angles are supplementary. So, you know that angle 1 and angle 3 are congruent due to alternate interior angles. And since angle 2 and angle 3 add up to 180, you know that angle 2 and angle 1 add up to 180 due to substitution. So now I'm going to show you how to put some of the theorems we've learned to use. So we need to find the values of x that make A parallel to line B. So I'm going to give you some time to solve it yourself, so pause the video here. Alright, so you know that angle 1 equals 3x plus 6, and angle 2 equals 5x minus 4. And to make line A and line B parallel, you need to make the corresponding angles, angle 1 and angle 2, congruent. So that means that 3x plus 6 has to equal 5x minus 4. So you can now you do 6 plus 4 equals 5x minus 3x. And so we're solving 10 equals 2x, or 5 equals x. So if x equals 5, angle 1 and angle 2 are congruent, which makes line A and line B parallel. Alright, here's another problem for you guys to try and solve. Pause the video now and try and do it yourselves, and then I will run you through how to do it. Okay, so what I do first here is I draw an imaginary line right here. And so if this is angle 1, and this angle here, which is 30, is congruent to this angle here, angle 1, since they're alternate interior angles, you know that this angle here is 30. And since then you have a triangle here, ABD, the angles in here have to add up to 180. So if one's 45 and the other's 30, you have 180 minus 75, or 105. So then you know that this angle here is 105. And since this length here, this angle there is 180, then you do 180 minus 105. Which is the same thing you did here, which just equals 75. So then you know the angle ABC equals 75. Alright, so now we're going to use what we know to solve a proof. So I want you to pause the video here and try and do it yourself, and then I'll walk you through it. Alright, so first off, when doing a proof, you have to write out the given. So you were given that line AC is a bisector of angles CDA and CBA. And you also know that line DA is parallel to line CB. This is given to you. The next thing you know is that angle 1 is congruent to angle 2 because they're both alternate exterior angles. Interior angles, sorry. You also know that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4 because of the definition of a bisector. You also know that line AC is congruent to itself because of the reflexive property. So knowing this, you know that triangle CDA is congruent to triangle CBA because of the angle side angle postulate, which says that if you know two angles and a side that are next to each other, those two triangles are congruent. You also know that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3 because of substitution. Because you know that angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3, so you know that angle 2 is congruent to angle 3, as well as angle 1 is congruent to angle 4. You also know that CB is congruent to DA because of the converse of ITT, which says if you know two lines are congruent, then the angles here are congruent. But since you know the angles, you know the lines because of the converse of that thing. You also know that DA is congruent to AB because of congruent parts of congruent triangles are congruent, which says that if these two triangles are congruent, then this line, which corresponds to this line, are congruent. And since you know that the triangles are isosceles, you know that CB and DA are congruent. And since you know CB and DA are congruent, you also know that CD